Today we're going to talk about sectors and composite shapes. So a sector is an incomplete circle. Any part of a circle that includes the both radii, okay, very much like a slice out of a pizza, or the amount of pizza that's been left. So it's some part of a circle that's been cut so that it's been cut along the radii, each radius. So that means that the radii left intact, they're not cut in any way. We're not cutting across the circle any other way but using the centre point as our starting point for cutting two lines out along the radii. Okay? So there'll always be some sort of angle associated with it, some sort of amount. So here the angle looks like it's less than 90 degrees. And here the angle looks like it's quite large. The angle looks like it's greater than 270 degrees and less than 360. It almost looks like we've had this piece of the circle cut out of this larger piece of the circle. So the amount that we've got, the amount of the circle that we have left is related to this angle. Now this symbol that we've got here, this symbol is a Greek letter. It's called theta, and whenever you see theta in mathematics, it often refers to an angle, almost always refers to an angle. So just as a review of angles, if we're going to go all the way around the circle, that's going to be 360 degrees. 360 degrees, you can think of a 360 degree spin, a 360 degree turn, a 360 degree flip, something like that, okay? It's always coming right back around itself, and that would be a whole circle going around 360 degrees. If we had half a circle, we'd only go half of that 360 degrees. We'd go 180 degrees. So 180 degrees, or 180, is turning around half a circle. So turning around so that you're facing the opposite direction. If we were to do a quarter of a circle, looking at a quadrant is 1/4 of that 360 degrees. It's going to be 90 degrees. So 1/4 of 360 is 90 degrees. Okay, so a sector's area is found by multiplying the fraction of the circle that is present. So the fraction of the circle that we've got left, we multiply that fraction by the area of the whole circle if the whole circle was present. So that means that the area of a circle with the same radius. So if the whole circle was present, we multiply that area by just the amount of that circle that we have present. So here we'd be multiplying by whatever that angle is over 360. Out of 360. So this angle here might be 60 degrees or something like that. So if that's 60 degrees, that's going to be 60 degrees out of the 360 degrees that would make a total circle. So here is the formula we've got. Area equals the angle, theta, divided by 360. So this is the fraction. This is the fraction of the circle that we've got. This fraction of the circle shows just how much of the circle we have left. So if it was 90 degrees, so if it was a quadrant, it would be 90 out of 360, which is just 1/4. If it was a semicircle, so half a circle, then it would be 180 degrees out of 360, and that would make 1/2. So that represents the fraction of the circle that we have, multiplied by the area of the whole circle, if the whole circle was present. So we're essentially saying we're multiplying or finding the fraction of the area that we have left after we've cut away some of the rest of the circle. So that's sectors. If we have a look at composite shapes, the word composite means to be composed of. So it means it's composed of more than one shape. We've taken a lot of shapes and we've put them all together. And we see this everywhere we look, especially in construction and things like that. We can put shapes together to make even more intricate and beautiful shapes that we can use for building, for artwork and things like that. So a composite shape is made up of more basic shapes. So in order to find the area of a composite shape, we can just add or subtract the areas of more basic shapes. So here we've got a composite shape that's got two different areas. We've got here, I've marked on area 1, A sub 1, and here this is A sub 2, or subtext 2. So these are two different areas. This is the area of a more basic shape, a rectangle, and here we've got the area of a more basic shape, a semicircle. So to find the total area, the total area is going to be this area plus this area. We're going to add them together. So the area equals A1 plus A2. So A1 here, A2 here, we're going to add them together. So the area of A1, that's the area of a rectangle, so that's going to be length times width, here L times W, plus the area of area 2. So we've got half a circle, a semicircle, so it's going to be half of the area of a full circle. So it's going to be half times pi r squared. Let's look at an example. The first example is going to look at sectors. So here we've been asked to find the area of these sectors correct to 2 decimal places. So here's our first sector. You can notice that we've cut along here the radii. So both of these radii are going to be the same length. This is going to be 2 centimetres and this is going to be 2 centimetres. And the slice of this circle that we've cut out is 120 degrees. So 120 degrees out of 360 degrees if we went around the whole thing. So the area is going to be theta, the angle, divided by 360 multiplied by pi r squared. So the angle that we've got left of the portion of the sector, of the portion of the circle, is going to be 120 divided by 360. So that's the angle, 120 here, multiplied by pi times r, the radius, 2 centimetres here, 2 squared. So plugging that into our calculator, we yield 4.18879. We've been asked to round to 2 decimal places. So if we have a look at the second decimal place here, the one next to it is an 8, so that means we need to round up to 4.19 square centimetres. So B here, we're going to have a look at our circle. We've got a sector here, and we've got quite a large amount that we've got cut out here. There's a 70 degrees portion has been cut out of our circle here. Now it's the 70 degree part that's been cut out, not the amount that remains. We've been asked to find this area here, and we don't have that value, we don't have that amount. So to find the angle that we've got actually left, this is the angle that we need to find, the angle that we've got left, because this is the portion, the area that we're trying to find. We're not trying to find the area in here, we're trying to find the area that's left, that sector. So to find that area, all the way around is 360 degrees. So if we take away 70 degrees from that 360 degrees, we'll be left with what we've got here. So the angle, theta, that we're trying to find, this one here, theta, is going to be 360 degrees all the way around, subtracting away the 70 degrees that we've had taken out. So that's going to be 290 degrees. So this amount here is going to be 290 degrees. The area of that sector that's left is going to be the fraction that's left, so 290 out of 360 degrees, multiplied by pi times the radius squared. And the radius we've got here is 5 metres, so 5 squared. Plugging this into our calculator, we get 63.268. Once again, we've been asked to round to the nearest 2 decimal places. So if we look to the right-hand side of that number, we see, or of that decimal place, we see that we need to round it up. So the answer is going to be 63.27 square metres. Our last example that we've got today is trying to find the area of a composite shape. So here we've got to find the area of this composite shape right here, correct to the nearest whole number of square millimetres. So let's have a look at the shape that we've got. Instead of adding 2 different shapes together, we've got one shape here and we've taken some away. So this could be, this area 1 might be the area of the whole rectangle, and we're going to take away this area of this quadrant here. It's a quarter of a circle that we've taken away. So we're just looking for the area in here, the area that we have left after having A1, the whole rectangle, and taking away A2. So the area of the whole shape, the area of the shape that we have left, is going to be A1, the area of a big the rectangle all the way around, subtracting away area 2, the area of this quadrant, this sector here. So area 1 is going to be length times width, the area of a rectangle. And we're going to take away the area of that quadrant. So that's 1/4 times pi r squared. If we were to have a look at this as a sector, the angle that we've actually got is 90 degrees. 90 out of 360. So 90 over 360, 90 over 360 is the same as 1/4. It's an equivalent fraction. So we've got 1/4 of a circle here, and we're going to take that 1/4 of a circle away. So 1/4 times pi times 10 squared. So our 10 times 20 is 200 square millimetres for our whole rectangle, and we're taking away 25 times pi of this area away. So plugging that into our calculator yields 121.46. But we're asked to round to the nearest whole millimetre, So we need to have a look at the value in the next decimal place to the right, and it's below. It's 4 or below. So we need to keep the number where it is. So 1 isn't going to be rounded up; it's going to stay as it is. So our answer for our composite shape, this shape here, is going to be 121 square millimetres.